Welcome back to our fascinating science channel, dear viewers. Among the 8 planets in our solar system, Venus is known as the planet with the largest albedo, reflecting up to 75% of the sunlight it receives. When observed from Earth, Venus appears very bright and is the second brightest celestial object in the night sky, surpassed only by the Moon, because Venus is an inner planet orbiting inside Earth's orbit. It can only be seen during dawn or dusk. This is why it is often referred to as the evening star or the morning star. With its albedo of 75%, Venus stands out as one of the few planets in the universe with such a high reflectivity. However, recently, scientists have discovered a planet with an even higher albedo than Venus, reaching an astonishing 80%. This newfound planet is being hailed as a colossal anomaly in the cosmos, becoming the planet with the highest reflectivity known to humanity. But what is the truth behind this story? Let's dive deeper and explore the world of exoplanets, which holds countless surprises. As of June 2023, scientists have identified them. Among these exoplanets, there's a wide variety of planetary types, including gas giants, exoplanets like Earth, and icy worlds resembling Neptune. Within this vast exoplanetary treasure trove, we have been astounded by the uniqueness of many worlds, each one unlike any other, offering a glimpse into the incredible diversity of our universe. Recently, scientists made a groundbreaking discovery, uncovering an exoplanet with an albedo higher than Venus, reaching an astonishing 80%. This exoplanet is named 9779 and was first detected in 2022 by NASA's Transiting Exoplanet Survey satellite. According to calculations, 9779's albedo stands at an unprecedented 80%, a record-breaking figure. To put it into perspective, Earth reflects only 30% of the sunlight it receives, while Venus, with its thick cloud cover of sulfuric acid, has an albedo of 75%. This makes 9779 the planet with the highest reflectivity known to humanity. However, how does this phenomenon occur? The answer lies in the planet's unique characteristics and composition. The albedo or reflectivity of an object is defined as the ratio of the radiated light from its surface to the amount of incoming light it receives. The higher the albedo, the more light an object reflects, making it appear brighter. 9779's exceptional albedo is attributed to its cloud cover, which primarily consists of silicate and nickel-rich clouds, similar to those found on Saturn's moon Titan. These particular cloud formations are excellent reflectors of light, causing 9779 to shine brilliantly. But that's not all. Saturn 9779 holds several other remarkable characteristics that are easily noticeable. It is believed to be a gas giant with a radius approximately 41% larger than that of Jupiter, the largest planet in our solar system. In comparison to Earth, 9779 boasts a radius approximately 5 times greater. Currently, the planet orbits a yellow dwarf star from a considerable distance, equivalent to about 262 light-years away from Earth. While this distance may seem vast, what is despite its seemingly inhospitable environment, 9779's high albedo or unique cloud composition suggests that it defies conventional expectations. Researchers are eager to unlock the secrets of this enigmatic planet, and its discovery has opened up new avenues for exploration and understanding within the field of exoplanetary science. As we continue to unravel the mysteries of our universe, 9779 stands as a shining example of the wonders that await us beyond our own celestial neighborhood. The cosmos, with its myriad exoplanets and celestial phenomena, never ceases to astonish us, reminding us of the limitless possibilities that lie beyond the boundaries of our own solar system. Named 9779, its exceptional characteristics continue to baffle and intrigue scientists, prompting in-depth research and extensive investigations. This mysterious exoplanet, with its extraordinary albedo and unique cloud composition, has raised numerous questions about its formation, survival, and the conditions that prevail within its extreme environment. One of the most intriguing aspects of Flat 9779 is its scorching temperatures, with a surface temperature that reaches a staggering 3,650 degrees Fahrenheit, approximately 2,000 degrees Celsius. This exoplanet exists in a state of perpetual heat. This extreme heat is far beyond what we consider habitable, even for the hardiest of organisms. Such high temperatures would typically result in the rapid evaporation of any volatile substances, leaving behind a barren, lifeless landscape. However, in its 9,779 challenges these expectations with its peculiar cloud cover. The clouds on this planet are primarily composed of silicate and meteorite materials, which play a crucial role in its exceptional reflectivity. The presence of these metal-rich clouds is a testament to the planet's unique chemistry. Unlike typical gas giants, Flat 9778 manages to retain atmosphere-rich metallic compounds, resisting the usual fate of volatile elements being stripped away by the intense radiation of its tail. The fact that such clouds exist in an environment where temperatures soar to thousands of degrees is a remarkable anomaly. Scientists liken the formation of these clouds to a process familiar on Earth, the condensation of water vapor in a steamy bath with an exposed cold air. In this analogy, the metallic compounds in Flat 9779 landed 70 months, but the equivalent of the water vapor, while the intense heat of the planet acts as the hot shower. The metallic clouds form as a result of these compounds condensing in the extreme heat. This explanation, while intriguing, leads to further questions about the planet's internal dynamics and the source of its intense heat. Researchers speculate that some 1,779's close proximity to its host star by its rapid orbital period, completing work ordered in just 19 hours, could contribute to its extreme temperatures. The planet's orbit is so tight that it experiences intense gravitational forces from its host star, which in turn generate immense friction and heat within its core. Another puzzling aspect of Flat 9779 is its high-density atmosphere. Despite its extreme conditions, the planet manages to retain a thick atmosphere that prevents the rapid loss of its metallic elements. This dense atmosphere acts as a shield, keeping the planet's unique cloud cover intact. Furthermore, Flat 9779 orbits its host star from a relatively close distance, approximately 0.26 astronomical units away. An astronomical unit is the average distance between Earth and the Sun, roughly 93 million miles. Although this may seem distant by human standards, in astronomical terms, it's remarkably close. This close proximity to its parent star, combined with its rapid orbit, presents another enigma. In such a hellish environment, it defies expectations by maintaining its higher fidelity. Typically, planets so close to us become scorching infernos. Their atmosphere is being stripped away by the intense radiation. However, with the 9,779's ability to keep its clouds and atmosphere intact raises fundamental questions about the dynamics of exoplanets in extreme proximity to their stars. The discovery of Flat 9,779 designated a forever of scientific interest, with astronomers eager to unlock its many mysteries. It represents a unique opportunity to study a super-hot exoplanet that challenges our understanding of planetary atmospheres and cloud formation. As we strive to comprehend the secrets of this enigmatic world, the exploration of exoplanets continues to push the boundaries of our knowledge. Each discovery, like Flat 9,779, offers a new perspective on the universe, reminding us that the cosmos is an ever-evolving puzzle waiting to be solved. In the coming years, Mach 9779 will likely become a focal point for fauna research, with astronomers using powerful sky-based telescopes such as the James Webb Space Telescope and the Hubble Space Telescope. With each new revelation, we edge closer to a better understanding of the vast and diverse exoplanet landscape that lies beyond our own solar system. The cosmos remains a source of endless wonder and astonishment in Enigma 9779, with its extraordinary albedo and mysteries. As we continue our quest to decipher the intricacies of the universe, we can only imagine what other remarkable discoveries lie in wait beyond the boundaries of our celestial neighborhood.